Welcome back to another stream. It's a new week, and I thought I'll be tackling the continuation of the AI development at the start of the week. It's been maybe 1.5 to 2 weeks since the last one. I don't actually remember, but I don't think we actually began the next exercise. I think we simply continue the tests, right? Yeah, we finished creating the test archives to simplify the testing process, which was a very big plus. But we also need... Then after that, we said let's continue to exercise 11, and then it gave us exercise 11, but let's see. Mini transformer, do we have a file called mini transformer? No, doesn't seem like that's the case. Then I guess that's the projects for today. So we have the mini transformer file, a Python file, a lot of stuff, and then we have tiny data, and this does something, and then we have train mini transformer, so it's the training script. And then we have the tests. Okay, neat. I suppose we should also, if we were to close torch, close all of them, and then we can move. I should want to move into archive, yes. Same with this test file. Now those are in the archive, and then we'd want to create a new file. Let's call that, see, what do we have here? So we want to create mini, I'm just gonna move my shit around a bit. Keyboard like so. Mini transformer .py. What else do we have? Tiny data .py, and why can't? That's annoying. Train mini transformer okay. And then we had a test file. Why can I okay. I don't know, sometimes you can use the middle mouse button to scroll, but sometimes you can't for some reason. And then inside the tests we create a test mini transformer.py. There we go. Okay. Notes you can ignore but might like later. This is a pre-norm transformer. It trains smoother on small setups. The causal mask is buffed once and sliced to current length for speed. Generate supports temperature and top K truncation for sampling control. Temperature, I know what it's like as a concept, I understand it. If you raise the temperature, you get more randomization and more natural sounding answers. But you also introduce more hallucinations. But if you have like no temperature at all, then you will only get one answer. there will be no like I don't know how to say it. It will be no it won't sound like a person when it responds. The text will be all rigid and it can get stuck in loops even easier, I think, and it's a fine balance on how much temperature you want and how much like rigidness you want. Because if you have too much temperature, then you simply be hallucinating everything, and that would be like gibberish, so that's not a good idea either. But yeah, let's see. So close those down and start with mini transformer. So from future import annotations, from data classes, import data class, import math, import torch, import torch.neural network as neural network, or nn, import torch.nn.functional as f. Data class model config. We create a, I don't know what the data class does specifically. I can ask. What is a data class in Python?
Sure, so a data class in Python is basically a neat way to create classes that are mainly used to store data. Instead of writing a bunch of boilerplate code to define things like an initializer or a representation method, you just use it at data class decorator. Then Python will automatically generate those methods for you. It just makes defining simple classes that hold data a lot cleaner and easier.
So it's not necessary, but a helpful addition.
Exactly, you've got it. It's not something you absolutely have to use, but it definitely makes your life a bit easier when you're just setting up classes to hold data.
Okay. So that's good to know. Then we vocab size as an integer. So these are variables for the data class. Block size as an integer, n layers, integer, equal that to 2. So neural network layers, probably. Or no, n layers, so the number of layers for the model is set to 2. And the number of heads we default to 2. And D model 64. D BFF int 256 dropout. Float of 0.0. I don't know what this is an abbreviation of. D model. I've already come to terms with the fact that I'm not gonna understand most of the stuff going on. I feel like I want to create the transformer and run it, like get it running. And then after everything like that, then step by step, maybe make additions of my own and like configure it towards my needs and stuff like that, but I shouldn't need to understand everything from the ground up to do that. And as this is a hobby project, first and foremost, I don't want to torture myself trying to get a degree in data science using ChatGPT. I mean, that's I have to be realistic. So we set the class causal self attention, and then that module we define a function in it called init, and we have parameter self, the model as an int, and heads as an int, block size as an int, drop out as a float, default to 0.0. Oh, wait, no, that, and let's see. So we say super init assert the model module number of heads equals 0. The model must be divisible by n heads. So we're checking that the number D model, whatever that is divisible by n heads, and it equals to 0. Because the module version, module operator, I think, the module operator will equal to 0 if it will give us the remainder after we've divided it, and that's will automatically be 0 if it's divisible. I'm not sure. And equal to 1 otherwise, because we're gonna have 1 remainder when it comes to integers, at least. Float numbers are of course a bit different. So self.dmodel equals the model self. Oh, we pass along self. Causal self attention, and then module. So we're gonna pass along, when we're creating this class, we're gonna pass along a neural network.module, and when the class initializes, we need to pass along the self, or is the self already referring to the class in itself? I don't know. I guess we'll see. But it's gonna set the model of the self to whatever we pass along, and we're calling the init function. And same goes with n heads. Set that to n heads. Ooh. And the head. Wait, the head. Oh, this is a new. It's probably not a typo, right? It's probably a new variable. Let's go along with it being a new variable for now. So set that to D model. Heads. This isn't divided by, right? This is something else. What kind of operator is 2 slashes? Like 2 divisions next to each other?
The double slash operator. So in Python, that's used for floor division. Basically, it divides two numbers and then it rounds the result down to the nearest whole number. So if you do something like 7 double slash 2, you'd get 3, because it's just taking the floor of the division. It's pretty handy when you want an integer result.
Otherwise, it would give a float, or would it round to the nearest integer?
Yeah, exactly. If you just use a single slash, you'd get a float as a result. So 7 slash 2 would give you 3.5. But with the double slash, it's always going to round down to the nearest whole number. So it's really just about whether you want a floating point result or a nice clean integer.
There's probably a way to also get it to round, well, to the nearest integer, or round up as well. Not round down all the time, but in this case we're rounding down, it seems like. So then we say self dot QKV. No idea what that stands for. And then dot linear v model read times v model bias false. So then in linear, this is a function. Is it a math function, or oh, it's a class? So set that to this class. Initialize internal module state shared by both NN module and script module. Okay, so we initialize in the module, internal module state. Well, we're not initializing the module, simply the module state, I guess. I don't know why we want to do it by using D model. I don't know what D model means. I feel like Can you explain this? I feel like they might come up a lot as we go forward, meaning that at least having a basic grasp on their meaning would probably be a good idea. I mean, vocab size is very straightforward, but the rest isn't that straightforward, to me at least. Crafting concise explanation. Explaining dimension and parameters. Tension. Here's what each field in model config means, how it affects shapes / compute, and how to pick values for your mini character transformer. Vocab size int. What? Number of distinct tokens, classes. Wait. Number of distinct tokens. But would you actually call that a... Well, of course it has to be a class, because we're gonna pick from them later and it only knows the tokens. So I guess the tokens are classes as well. Never thought about it that way, but I guess the vocabulary is as much important as, like, for the transformer to understand as well as speak back. Okay, where it's used. Token embeddings, embed weight, shape, vocab size, D model. So when a weight from a weight to a shape. Ooh, here we have D model as well. Output head. Head.weight. Wait, what is a head though? Shape, D model, vocab size. So they are flipped. Effect. Bigger vocab equals more parameters in both embedding and output layers. Typical. Character tokenizer 70 to 150 byte/byte BPE 256 to 1K plus. Okay. Block size int. What? Maximum context length. How many previous tokens the model can see? How many of previous tokens the model can see? Okay. So I guess this is the when the large AI companies talk about context length and token limits and stuff like that, when they have like in the millions sometimes. I think Gemini has like 1 million token like context length, I think. Or it might be 100k, I don't actually remember, but it has a lot. Where? Positional embeddings. So, block size, D-model. What is D-model though? I feel like I almost need to read that first. Castle mask. Block size. Block size. I don't know what a castle mask even is, but I'm gonna ask. What is a castle mask?
So a causal mask is something you often run into in things like transformer models. Basically, it's a way to make sure that when a model is predicting something in a sequence, it only pays attention to the elements that came before it, not the ones that come after. In other words, it prevents the model from cheating by looking ahead. So you just mask out future positions so it can only see what it logically should see up to that point.
Okay. Training crops to length. T equals block size. Generation crops to last block size tokens. Attention cost grows as O times T up to the power of 2, doubling block size. Quadruples, approximately quadruples attention compute / memory. Okay, pick start 64, CPU friendly, try 128 later if training is stable. N layers int. Number of transformer blocks stacked. Effect. Deeper. More capacity / compute. Each block adds attention plus MLP parameters and T to the power of 2 attention work. Pick 2 to 4 for CPU toy runs. You can bump to 4 once things work. Okay. N heads. Number of attention heads per layer. Constraint, the module N heads equals 0, so that the module equals the model divided by N heads. Lord. Effect. More heads equals more subspaces to attend with. Same total width if the model fixed. Cost. Attention compute scales with N heads times T up to the power 2 times the head, which is approximately the model times T up to the power 2 if the model fixed. Pick 2 for the model 64. 4 for the model 128. Okay, so now I have the model. What? Model width. Embedding / hidden size. All token / position embeddings and block internals use this width. Effect. Strongest lever for capacity and parameter count. Must be divisible by N heads. PIC64 very small, fast, 128 still CPU doable but beefier. DFF. What inner width of the feed forward MLP inside each block? Rule of thumb DFF equals 4 times D model. So that's why I have 256 in this case. Big chunks of params compute lives here, 2 linear layers. D model to DFF to D model. Dropout float. What? Regularization. Randomly drops activations during training. Effect helps prevent overfitting on larger models / datasets, can hurt tiny setups. Fix 0.0 for your tiny CPU runs, try 0.1 if you know it's overfitting on a bigger corpus. Corpus, this case being a bigger vocabulary. What is overfitting? What is overfitting in relation to dropout?
So overfitting is basically when a model learns your training data a little too well. It kind of memorizes all the little details and noise in the training set instead of generalizing well to new data. Now dropout is a technique to help with that. During training, dropout will randomly drop out or ignore some of the neurons in the network during each training step. That helps the model not rely too heavily on any particular neuron and encourages it to generalize better. So in short, dropout is kind of a trick to reduce overfitting by making the network a bit more robust.
That's actually fairly interesting. I can see the logic behind it. Like if you were to have random failures in the network, then you'd have to be able to compensate somehow without getting terrible results. Which means you'd have to adjust the rest of the neural network to compensate for that failure point. And if you do that enough times, you would get a more stable base. That's less specific, but still more stable. But I guess you'd have to be careful as well to not go the other way around and make it too generic. So quick shapes inside the model with defaults. Oh, okay, so we're getting a lot more information here. Let's quickly read through it. Quick shapes inside the model with defaults. Assume vocab size equals 100, block size equals 64, D model equals 64, N heads equals 2, D head equals 32, and D FF equals 256. Embeddings. Token embed weight would be 164. Because we have a vocabulary size of 100 and a block. What's the model size? It could either be block size or model size. And then position embeddings dot weight 64, so that could be block size 2 times or model size 2 times. Per block. QKV linear 64 to 3 times 64. I think this is block size, right? Wait, I don't know. This is a bit too abstract for me to wrap my head around, I think. Parameter count, ballpark. Embeddings, output head. Defaults, how to sort. Choose values. We already have pretty good default values here, so I guess that's irrelevant. Gotchas to avoid. Assertion error. D model must be divisible by n heads. We already implemented that here, so that should be fine. Fix either value. Increasing block size later needs a new or extended positional embedding. You can't just load old weights with a smaller position table. Changing vocab size changes the beddings and head shapes. Retrain or map old weights carefully. Okay, interesting. But if we go back here. So, where were we? The NN linear. Here, self.qkv. Very difficult to say that fast. QKV. Project maybe, and then dot linear or projection maybe. D model and bias equals false again. Self dot 10 tension drop then I guess, and then dot drop out, and pass along the dropout parameter, which is 0 in this case. Self dot residual drop probably, and then dot dropout. So set that to the same thing. That's probably a residual since we already do it once, perhaps. Maybe. That feels shaky, but maybe. Castle. Mask. 1 ET. Lower triangular. True where allowed. And mask torch dot fill. Torch 1's block size. B-type torch dot fuel. There we go. Register buffer. Castle mask. Mask persistent. False. Ooh, and then we have another function. So this was the initialization function. Then we have forward. Self x torch.tensor. And we want to return a torch.tensor. So BT and C to equal X shape. So the X of shape. Is that 3-dimensional then? It has to be. We even have a comment for it here. Batch. Time and channels. D model. This has to be the 3 dimensions, right? Probably. And QKV. Self.QKV X. And we want that is B, T, 3C. Okay. UK and V. QKV dot split, so we split it up. And dim to for two dimension then perhaps. Reshape into heads. Still not entirely sure what heads is all about, but whatever. We're moving along. Self dot n heads. Self dot d heads. No, d head. Nearly a typo. Dot transpose. 1, 2. Interesting. What does it mean to transpose? Maybe change the position? I'm gonna ask. What does it mean to transpose?
So to transpose basically means to flip rows and columns. For example, if you have a matrix, transposing it just means you're turning all the rows into columns and all the columns into rows. It's a super common operation, things like linear algebra, and it just helps you rearrange data when you need to look at it from a different perspective.
Okay. So we're transposing that, and then we're doing k equals k dot u bt self dot n heads self dot d head, and likewise transpose that one to 1 2. And v equals v dot view bt self dot n heads self dot d head, and the same thing once again, and there we go. Then we say scaled dot not it dot product tension scaled dot product. Let's see, at q a dot transpose. Oh, hello, what's up? Doing some programming, trying to create a mini transformer for a language model. Everything good with you? Do math.skirt self d head. I'm trying to program an AI of my own using ChatGPT. It's going slowly, very slowly, but slowly is still going somewhere, so I'm plugging along. Are you interested in programming yourself? Can I paste that? No. PTT. I think I didn't do any typos. No. Like castle mask. I'm learning. Or I'm not like having the AI give me code and copy and pasting it. I'm having it give me lessons. So this is exercise 11. And following me along and asking questions, trying to understand it. I don't want to vibe code. That's I don't know if you can even vibe code an AI with another AI. That feels like too advanced for it to understand. I don't know. I mean, you can get lessons, so maybe. Have you used AI for learning, like programming or anything like that before? Where was I? Here. Play castle mask. Up to sequence length. Ooh, research. What are you researching? with self castle mask. Before I started developing my latest project, did some research on YouTube CSP structure. What is CSP? Why is it complaining? Yeah, did I? Content security. Ooh. Okay. Scare all the bots, man. All the damn bots. Content. Okay. But are you using AI to do the research, or are you researching like YouTube's use of AI? Why is this complaint weird? How do you make that symbol like that? I think. Mask. Float. Inf. Negative infinite. I'm also looking into how people get around. Oh. And how I can use it in my projects. I'm trying to get around the content security policy. Man, that sounds not... I don't know, sketchy. What are you up to? That you need to block their content policies. Oh, interesting at least. Let's see. I see. Some sort of... Well, replacement might be the wrong word, but... Or maybe it is a replacement, like for the standard web client of YouTube. I think so. I've never used that, but I've heard of it. So it's something similar to that, I suppose. And maybe like the content blocker as well, like uBlock Origin, both in one. It's fine. It's fine. Well, I'm trying to make an AI. I want to... There's so many things you can make when you have your own AI. Things to do with it. But my plans for it, as of now, is simply to have it like my own TTS bot that has its own like built-in functionality and stuff like that. I feel like that would be a good first project for it, because then you could get like some input from chat. Like if you were to type something, you could also have it recognize commands like the other bots, like I don't know, maybe say it's hello or something like that, and then there's a specific like sequence it prints from that one. Oh, thank you so much for the follow. But honestly, this is mostly a step project for myself, for a hobby. I think AI is very interesting, even though there's so much bad stuff going on with AI right now. There's so much good stuff as well, and I want to understand it. And I feel like the best way to understand it is to make your own. Even though I'm following closely in the steps of whatever ChatGPT spits out. Continuous. Is that how you spell it? Contiguous. That was difficult to spell. BTC. BTC. And I have self.resid drop. Why? Ooh. Thank you. Oh. Well, thank you for going AFK on my stream at least. Self-resid drop. Wait, no, just... Oh, underscore resid drop. There we go. Still don't understand what this is. Console mask. Is it... Mask. Go to search castle on, and here we have castle mask. So we do have a reference to castle mask, and it's spelled correctly. So it's spelled correctly and everything, but it's still complaining. Why? Why? Register buffer. Is that the one? Register buffer. Resistant false. No, it's everything. It's the same. Function with declared return, that's not the one. Get a method not defined on type module. I'm gonna take a short bathroom break. I'll be right back. And we're back. See, I'm just gonna check quickly, and it seems I dropped some frames in the beginning of the stream. Just gonna check that's fine, and it seems fine. Haven't dropped any frames since that point. Okay, and we also have the little chest with a duplicate. Too bad. Okay, so method not defined. I'm just gonna pretend that's not there and continue, and then at the end, if there are errors, then we can ask the AI. That's probably the best way to do it, I think. Honestly, I had no idea. I'm just making stuff up as I go. I want to return Y. And that's that one. Then we have the class MLP. Pass in a neural network module. And define a function called init. Reference the self probably model, and that's an integer. BFF integer dropout float, default that to 0.0, and we do super init. I don't know if this means that we call like this function as a super user on the computer. Maybe. And I mean like a super user as in an administrator. I think it's called a super user on Linux though, I think. Not entirely sure. Self.fc1 equals nn.linear dmodel bff. Self.fc2 equals nn.linear bff and dmodel. And then self-drop equals nn.dropout dropout. Def forward self x torch.tensor return self.drop self fc2 f.yellow self this is spaghetti code elf.yellow self.fc1 x. Yay! I'm not even gonna pretend I understood that one. Then class block, not black, block, and then dot module, and the same thing again with it. CVG model config. Okay, is this another class? Yeah. And likewise again, we call it by super init. I haven't thought about it before, but isn't this like self-referencing logic that makes it loop? Or is it more saying like, if you call this function, then it automatically sets this function to be a super or super user maybe? Let's see. I should probably ask what this does. What does super do in Python? Like super and then dot function name.
Yeah, so in Python, when you use super and then call a method, you're basically calling a method from the parent class. It's really handy in inheritance because it lets you extend or override methods in a child class but still reuse the logic from the parent. So in short, it's like saying, hey, go ahead and run the parent version of this method as well.
And what is the parent method? Like I have a class with a function called init, and the first line inside that function is super init.
Right, so in that example, the parent method is basically the unit method of whatever class you're inheriting from. So if you've got a child class and you put super.unit.unit at the start of its own initializer, you're basically just making sure that the parent class's initialization runs first. It's a way of setting up everything the parent class needs before you add any extra stuff in the child class.
And then when you call init in the the lowest hierarchy, like the lowest position in the hierarchy, then it will initialize each class before it. Like we'll go from the oldest to the youngest, or to the highest to the lowest.
Yeah, you've got the idea. When you call that super.unit chain at the lowest level of your class hierarchy, it works its way up. So it starts from the most specific child class and then goes up the chain, initializing each parent class in order from the topmost parent down to the one you're currently in. Basically, it makes sure that all the parent classes get properly set up before you do any extra stuff in the child.
Well, that was interesting and good to know. Good to know. So let's continue. So we have block and we have the super stuff, and then after that we have ln, I think it's ln1 equals, and then dot layer norm cfg d model self dot attend causal self attention cfg.dmodel cfg.enhance cfg.pocket size and cfg.dropout. And that's spelled correctly. Nice. And self.ln2 and then layer norm. Layer norm. cfg.dmodel. And self.mlp. MLP capitalized. cfg.dmodel. cfg.dff. cfg.dropout. And after that we have forward self x torch.tensor. Want to return a torch.tensor, not tensor. X equals x plus self.10 self.ln1 x, and x equals x plus self.mlp self.ln2 x, return x. So this is the block class. Okay. And then we have class mini transformer. And then module. So minimal PPT style decoder only transformer pre-norm, probably pre-normalization perhaps. Let's see, what else do we have? So what's up? I also took a short break. So yeah, we both took a break. I'm now at the last class for this, for the mini transformer pi script. So we need to initialize that one as well. Are you working on your own project right now, or are you like just relaxing, chilling after a long day? So CFG, okay, bed and settings. Oh, that's very late. That's very late. Or early. Yeah. It might be worth to go to sleep, maybe. I don't know. I shouldn't talk. I'm a night owl. I simply can't sleep early. I need to be like utterly exhausted to be able to sleep. College, yeah. But if you're, say, about 2 hours ahead of me, then you're probably in Eastern Europe. Probably. Maybe further east. I don't know. I have zero knowledge about time zones, to be honest. Turkey. That's pretty central Europe still, right? I mean, Germany is central, and I guess Turkey is a bit further east. Yeah. But not that eastern either. Turkey. Wasn't there like some pretty insane fires in Turkey this year? GMT +3, okay. Yeah, I don't know, I think, I thought it was Turkey that had crazy fires or something. Maybe I just read that wrong. You can see it from Asia. Oh, I thought Turkey were European, but maybe not. Wait, no, Turkey is in the European Union, right? So it has to be Europe, right? Oh, right in Europe while I'm talking. Drop and then drop out. CFG, drop out. It's not in EU. Well, I guess you would know since you're living in Turkey, but I thought they were in Turkey or in Europe. But they're in NATO. I suppose most countries are in NATO. Feels like it at least. But what do I know? I honestly have zero knowledge about like Middle Eastern countries. Module list. But if you're in college, what are you in college for? Is it data science perhaps? I mean, if you're doing Git projects on your own, then that would be my first guess. Software engineer. That's pretty broad. Is there like a specific software engineer you'd like to be? I actually went to school for game development, but the school managed to kill that passion in me. So I don't do that anymore. I worked in IT for a while after school, but yeah. And then linear. I don't even know what you can be today when you go like becoming software engineer, except for like working with AI. It feels like AI is taking over everything. Everyone is talking about AI this and AI that. But I guess there has to be positions outside of that. Hopefully. We can only hope since you're studying for it. Init. Yeah, No, I suppose that depends. You can go pretty far with game development, but I simply didn't. I lost my passion for it. Do you have any idea what you actually want to program? Like what you actually want to develop? Maybe you're not a pro... Well, are you a programmer? Do you need to be a programmer to be a software developer? I feel like you can still be classified as a software developer, even though you're like not writing code, but like, I don't know. Maybe not. I was thinking about like data analysts and stuff like that. You need them in some like software, but they might not be called software developers, even though they don't write code. I don't know. Why is this code complaining? It's the second module can be assigned to if and time. I'm just gonna move on and then later go through all the errors. Oh, wait. Good idea, since it seems like we're setting up the actual function here. Module. If is instance. mn.linear. Computer sciences. I'm not entirely sure what the difference is between a computer scientist and a software engineer. Is it like a software engineer creates the backbone and the scientist uses the scientific software to do science? Computer science is more general. Okay. So it's broader. Might result in more job opportunities, maybe. Embedding. Software engineering is more about software, and computer science is about all parts of computer software, something. Okay. Okay, I think I get it. So you like programming then, since you're doing like the software part, or studying for that now. What language do you program in? Or do you learn like a lot of different languages? I guess Python is like one of the most common ones right now, right? Or maybe it's Java. I honestly don't know. Or maybe C++. Python, C, JavaScript. Java projects. So you're holding on to those secret projects. You need to do like a large project for school, like to graduate or something like that. I'm just curious. I don't know how like that sort of education works in Turkey, because I guess that differs quite a bit between countries. When did you start? I started with game development when I was like... Ooh, how old was I when I created my first game? I think I was... I might have had my 11th birthday, but I think I was 11. Might have been 10, but no, I think I was 11 years old when I did my first game. $14 or $15. That's still really young. Oh, so you had a friend interested in that. It was actually a friend getting me interested in game development as well. Logits. Where Logits is. BTV. Which is your favorite language, would you say? Since you said Python, C, JavaScript, and some Java. Ooh, itch. Let's see what you got. Oh. Oops. I did not mean to do that. Somehow managed to break my chat window. Wait. Let's see. I think I somehow managed to open your link in my chat window. I didn't even know you could open like that as a browser window. Well, the more you know. I got a a tiny bit of an impression of your each page there before that crashed. Assert itself, so see the block size, sequence length is greater than block size. Well, have a good night. Yeah, have a good night. Bye. Thank you, and you too. Good luck with your school and everything. And hopefully I'll see you back. I read this as a range, but it has to be a range. Or is it? How do you... Wait, what? Is that how you spell arrange? It probably is, isn't it? So you're arranging the positions, probably. Okay, interesting. Ooh, and also need to actually pass along the... no, dot unsqueeze. 0 1t x equals self dot hook embed idx plus self plus m plus PTD model x equals self drop x for BLK in self blocks. So we loop through those and say x equals BLK x tiny x, not large x, tiny x, and then x equals self dot lnf x and logit equals self dot head x PTB loss none. We don't want any loss if target is not none. If we have targets, then we flatten for cross entropy. So we have B times T and V versus B times T. So loss equals F dot cross entropy. What was the F functional? So we have cross entropy logits reshape -1 logits dot size -1 and targets dot reshape -1 return logits loss. So that's the forward function. And then we have another function in this class. Is this the first class with a third function? They have init forward, init, yeah. So this one is the first one with another function. And this one is the generate self idx torch.tensor max new tokens int of temperature float equals 1.0 top k and that's as an integer or none equals none. I think that's or, right? You call it the pipe, right? Or you call it a pipe in... Is it in batch script? Bash script. I don't know. No idea. Okay, so the comment we have auto regressive sampling and idx as a b t of context t can be less than or equal to block size for underscore in range of max new tokens. Then idx cond equals idx of minus self dot cfg block size space colon. So crop to block size. And then we'll log it. Underscore equals self dot idx self of idx cond v tv logits equals logits -1 colon divided by max temperature. So here we have temperature coming in, temperature IE -8, so a very small number. And last step, if top K is not none, V underscore equals torch dot top K logit top K thresh. What is thresh? Threshold perhaps. V is threshing an action as well, like you could thresh someone with a branch or something. I don't know. It's probably not what it refers to in this case, but still. And what do we have? Thresh -1 logits equals torch dot where logits is less than thresh torch dot full like logits and float negative infinity and logits seems to be correct. And probs equals f dot softmax logits dim -1 next ID plus torch dot multinomial probes and num samples plus 1 hashtag b1 and idx equals torch dot cat catenate or whatever you say, maybe idx next id and dim1 return idx. Okay, and that's something, all right. It will be a miracle if the test script returns everything as functional after all of this. But this is certainly a good use of the test script to check that everything is working as it should, because there's a lot of characters here that could be like pointed in the wrong direction, etc. Like when I played that game, the farmer was replaced and had issues for, I don't know, an hour and a half, and the issue was a symbol like this being pointed in the wrong direction like that. Took so long for me to figure that one out, and there could be an issue like that in here as well. But the tests should hopefully minimize that risk. And we still have this error here. It's the only error. But now would be a good time to provide, oh my god, terminal, to provide the, can I copy? Provide the AI with the error message, as well as maybe clarify which line it is on to make sure it understands. Where are we on? We're pretty high up, right? Somewhere here. Self. Here. Apply castle mask to sequence length t. Mask self dot castle mask. TT. Yeah. So if we were to mark that one, that should be enough, and we paste this. Wait, maybe I don't need. Yeah, let's paste everything. Oh, and get the chest. Another duplicate. Too bad. Explaining pylons fix. Wait, so it's not actually an error, it's a pylons issue. You're seeing that because pylons can't infer the type of an attribute created via register buffer. It assumes self.castle mask is some generic module, so slicing okay, looks illegal. I don't know what you want to call this one. Or maybe slicing is... This means slicing, perhaps. What's happening? Self.register buffer, castle mask, and... Register buffer dynamically adds an attribute. Static type checkers don't know it's a torch.tensor unless you tell them. Fix pick one. Option A, annotate the attribute cleanest. Add a type annotation before registering the buffer. And annotate the local 2. And okay. So this one is exactly this. No, it's not the same. I'm probably gonna do the cleanest one. It's a bit of extra code that might confuse me later. But wait, torch trim, torch 1, block size, D type torch, dot cool. So we simply need to add one line here. Self.castle mask as a torch.tensor. And then we tell pylons it's a tensor. And wait, it stopped complaining. So we don't even... Well, let's do this one as well. Wait, no. So mask torch.tensor. That was the only change, right? Yeah. And I did a annotate the attributes. Simply gonna put that there so the AI knows. It might not be that relevant since it has no impact on the code itself, but it's probably good to actually say that I'm doing this one, so it doesn't assume I'm doing all three or simply doing the other ones. But I honestly think this is a good spot to stop for today. It's only one script, but still. It's been a while, and I want to stop while I'm ahead. And it feels like this is a good spot for that. So, yeah, I'm gonna call it here for today. Thank you so much for watching. And if you want to see more, then you know what to do. And until then, have a great time. Cheers!